Hey everybody, welcome to week 2. Congratulations on making it this far. This video for this week is probably going to be a little on the longer side. What we're going to look at is a bunch of stuff that you already know from Python. So the if statement and the while loop, which hopefully you're pretty familiar with from your programming fundamentals course. I'm going to show you the Java syntax, and then there's a bunch of little things that you need to know about how stuff works differently in Java. So we're going to look at variable scope, we're going to look at the special case of Boolean expressions with strings, and so on. So there's a fair bit of content here, but we're really leveraging, hopefully, what you already have learned and reinforcing what you've already learned in Python. In the next few videos, then, we'll go through basically some alternatives to if and while. Java, like most C-based languages that are based on C, contains other loops. It contains a for loop and a do-while loop, and it contains another form of a selection statement, of an if statement, called a switch statement. And these are pretty standard bits of syntax. Since the C-style syntax, you find it everywhere. JavaScript, PHP, C#, Java, obviously, C and C++. So you see this syntax all over the place. So it's really good to learn all these different forms. They don't add anything, though, to the power of the language. 3 different kinds of loops is no better than 1 kind of loop in terms of the problems that you can solve. They're just conveniences. They're just syntactic conveniences that work a little bit differently or that look a little bit different. Same thing with the switch statement versus the if statement. It just adds an alternative syntax that some people like better. So really, after today, you'll be able to solve, after this video, you'll be able to solve all of the problems that you could have solved, I think, or most of the problems you could have solved in your Python course. And then we'll add some other bits of syntax that don't really increase the power of the language, but that are important because a lot of people like them and use them, and you'll see them everywhere. Okay, so let's get going. I'm going to just start up IntelliJ here. And while we're waiting for that, let's go over to the modules here. We are now in the week 2 module. I have to close this. Here it is. Right, so I haven't added the videos here yet, but we have a guide, and there's a little bit of an extra thing that we'll take a quick look at. And the example code is here as usual. I'm going to go get the example code for this week. And so we'll download it, and once I've got it, I will extract it to the desktop, and then I will put it into IntelliJ. So I just copied that, and then I'm pasting it here. So I have the folder here. Moved my recycle bin for some reason, and then let's get, here we are. So I'm in IntelliJ. I'm going to start a new project. Takes a second here. There we go. Next, and I'm going to call it, project name is going to be week 2 video examples. There we go. Here it comes. And then I will open up my project folder here. Come on, you can do it. There we are. And I will go into week 2 video examples, find, this is, going to example code. I will copy this, Control C, and I will paste it over here into my source folder. All right. I am ready to go. There's my week 2 code, and I'm just going to add, by right-clicking here, I'm going to add a new package. So I'm going to keep that initial code separate. I'll call this just new code, like that. Okay, so let's take a quick look at the guide. There's a lot of reading for this part of the guide. Like basically, the textbook that we have is an intro textbook. It assumes that it's an intro programming textbook using the Java language. So we're about to just steamroll over chapters 3 and 4, which are all about if statements and loops, because you already know that stuff. So we're really just going to, if you want to dig deep into it, you can take a look at those sections in detail. I think just skimming them is probably going to be enough, including, you know, in addition to these videos and to the guide. It'll probably, we'll slow down and cover less stuff in future weeks when we start doing object-oriented programming. But like I said, so this stuff spans 2 chapters in the book, but only 1 week here because you already really know most of it. Okay, so let's talk if statements and while loops. And I guess what we'll do is I'll create, rather than just going through the guide, I'll create a new Java class here. Call it if while. There we go. So there it is. Yeah, I'm going to make this a little bit bigger, just zoom in there. And then I'll just do psvm tab to get my main method. And I'll create a scanner, which I'll call sc instead of input because it takes less time to type. New scanner system.in, like that. And it is Alt-Shift-Enter, I believe. Alt-Shift-Enter will automatically get me, fix the import for me. Okay, so now I can get input from a user. I can ask them questions. So let's say, for example, system.out.println, how old are you? Let's get an integer from them. And then we'll do int age equals sc.nextInt. And that should get their age. And now let's say we want to classify them as a minor or an adult, right? So I think the age of majority in Ontario is 18. So if they're 18 or older, they're an adult. Otherwise, they are a minor or a child. That's an if statement. Now you've done this in Python before. The syntax looks a little different here. If this was Python, we would do this. If age greater than or equal to 18, colon, like that. And then we would indent this block down here to say, you know, print you're an adult. Something like that. So very similar syntax. We use the if keyword, but we have to, a couple of things. We have to bracket the Boolean expression like this. And instead of using the colon there and then indenting for the block, the block is defined by curly brackets like that. And of course we need a semicolon at the end here as well. Okay, so that's what it looks like. Blocks of code like this. In Python were just done through indentation. We still indent them in Java, but we indent for human readability, not for the. There's nothing like, it doesn't matter. I could do it like this if I wanted, and the program would still read it easily, perfectly. It's just that it makes it harder for a human to read when you do stuff like this. So white space, tab spaces, extra lines, they don't mean anything in Java. But they make the code much easier to read. This should be system.out.println, like that. And by the way, I just want to remind you that we do have, if you do stuff like this, Control-Alt-L is this automatic formatting thing that will fix all your indentation and stuff for you. Right, so this little program will run now. Control-Shift-F10 will run it. Then we'll say, how old are you? If I say 17, it should say nothing because the if statement doesn't fire. But if I run it again and say 18, I'm testing the boundary conditions here, testing the boundary where it changes from one thing to the other. It says you're an adult. Okay. Now let's say we want to know. Well, we can add an else clause to it as well. Is what I want to say. System.out.println. You're a minor. So there you go. There's a simple if statement with an if clause and an else clause. You can of course put as many things as you want in here. So maybe if you're an adult, access is granted to whatever it is we're doing. Otherwise, you're a minor. Please leave immediately. You're not allowed here. Okay, so I can put as many statements as I want inside of these curly brackets. So this, notice when I click here, the IDE IntelliJ is showing me how the brackets line up. Okay, so that's an if statement. If we want to do a while loop, well, is there anything more to say about if statements here? Yeah, we might want to do something like this. So that's one thing that we might want to do. We should probably talk a little bit more about Boolean expressions. So let's say we want to know if the person is between 18 and 65 years old. So in Python, you would say if age is greater than or equal to 18 and age is less than or equal to or less than 65, let's say. We want to know if they're an adult but not a senior. And is not a keyword in Java. Instead, we use double ampersand like that. So now we can say system.println, you're an adult but not a senior, like that. And we can use an else if like this. Now in Python, there's a special keyword for that. It's elif. But there is no special keyword for it in Java, so we just chain them like this. Else if age is greater than or equal to 65, we can say you're a senior. Else you're a child. Okay, so that covers the three cases. There's a little else if chain. If I run this again, if I say 19, the first one will go, you're an adult but not a senior. If I say 66, it'll say you're a senior. And if I say 17 or 16, it'll say you're a child. Okay, so I got two if statements on the go now. This one is showing what I would call an else if chain. By the way, as a lot of people are tempted always to do this, if age is less than 18. So here we're saying if age is greater than or equal to 18, do this. If that's false, then this must be true. So there's no need to put it here. There's no need to put this extra if. Just use an else. In fact, putting the extra if is problematic. It makes the code a little harder to read because it looks like maybe there's a case that's not being caught. And it also opens up your code to errors. So if you're writing an extra Boolean clause here, you might make a mistake. So that's a sure sign of a novice coder, doing another if when they don't need one. So try to avoid that because it makes you look like a noob a little bit. Okay, one other thing I should show you is that it's typically we have a block of statements after an if or an else if or an else. But if you only have one statement after it, you don't actually need this. Okay, so if the rule is after an else or an if, you either put one statement like this or you put a block of statements. And here's another little gotcha that can happen. You can write code that looks like this, and especially if you don't hit Alt-Control-L very often, this statement looks like it belongs to the else because of the indentation, but it doesn't, okay? Because I forgot to put my curly brackets, only the first statement belongs to the else. So to show you this, if I run this here, now when will this fire? This will fire if they're less than 18, so let's make them a senior. So what you'll get is you're a senior, and then yes, you're really a child, because this is equivalent, what I've written here, if I go Control-Alt-L, you'll notice it indents this back to show that it doesn't belong with that else. What I've actually written here is equivalent to this. So this statement here is not part of the else. If I want it to be part of the else, I have to use the curly brackets and put it inside. So because of that, because of those kinds of errors, most programmers will tell you always use the curly brackets. It makes the code more readable and it makes your code less error prone. But you can, this is legal if you only have one statement here and means the same thing as if you put the curly brackets on it. But we're not gonna do that. Put my curly brackets back. Alt-Control-L will rebalance it. Okay, so that's your and. There's also an or if age, let's say, is equal to 19 or age is equal to, I don't know, 29. We can tell them their age is a prime number. How about you're in your prime? There's a little joke. Okay, so this is an or. So where you would write or in Python, you write or like that. Same rules as in the Python. This if age is 19 or age is 29, then it will go off. And just to be complete, the not, so you can say if not age equal to 19 or age equal to 29, like that. So this is the not operator right here. In Python, you would say not like that. In Java, you say not like that. Okay, so that's how you do the not. That's a not and an or. This is an or. I'll post this stuff later. And this is an and. Okay, I'm just putting these in as examples. Yeah, and you have the same operators. So exclamation mark equals is not equal to. You've got greater than, less than, greater than or equal to, less than or equal to, and double equals for equal. So there's the same 6 operators that return Booleans, and then there's the and, the or, and the not. Okay, next thing I want to show you is the while loop. Okay, so again, it's just like in Python. You can do something like this. You can say system out print line, enter countdown number, like that. And then I can do int n equals sc.nextInt. Okay, so I'm going to get a number, and then I'm going to count down from that number. So if they enter 10, I'll count down to 1, and then say blast off or something like that. It's one of my favorite things to do in these simple demonstrations. So I'll do something like this, while, and again, it's the same syntax really as Python, except you have to bracket and use round brackets for the Boolean expression, and then use curly brackets for the block that follows it. So while n is greater than 0, I will do system out print line n, and then I will do n. Now you can do n equals n minus 1. I'm trying to count down here, and then I'll go system out print line blast off. So when I run this program now, I'll have to get through the if statements first. How old are you? Whatever, doesn't matter. Okay, enter countdown number. I enter 10, and I get this. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, blast off. Okay, so again, hopefully you did loops like this, counting loops and other kinds of loops in your Python class. You know, you put anything here that evaluates to true or false. The Boolean type itself, I already showed you. You can create variables of type Boolean as well if you want. But this does it. I did want to show you this. This exists in Python, n minus equals 1. I don't know if you will have seen it, but anytime you want to do like x equals x minus something, or x equals x plus, or x equals x times, you can do minus equals, plus equals will add to it. So if you go n plus equals, so if I go n minus equals 2, that's the same thing as n equals n minus 2. So let's do 20 and then do 20. So now it's counting down by 2's. See that? But if you're going to do minus 1 or plus 1, n minus minus subtracts 1 from n. This is something that's not in Python, but is really common in other languages. And n plus plus adds 1. So these are called the increment and the decrement operator. Okay? So increment would be n plus plus. So just to prove it to you, this works. Let's say I'm 5, enter countdown 5, 5, 4, 3, 2, 1, blast off. We could make this a bit more dramatic maybe if we did a thread.sleep. Haven't done this since the live class, I don't think. 1,000, so we'll sleep for a second. And this has an unhandled exception. You have to add throws interrupted exception. So what I'll do is I'll do this one. Alt-Shift-Enter will fix it for me. What it does is it puts this little piece of syntax up here. We'll talk more about exceptions later on, actually. Much later in the course, we'll do something called exception handling. You can certainly look it up on your own. Let's do 10, so now it's going to count down 1 per second. You can look it up on your own. It's called the topic is exception handling. And it'll eventually become useful because right now in all of our programs, when we ask for numbers, anytime you ask for user input, you're giving the user the opportunity to break your program. So if I say hello instead of typing a number, I get this horrible block of text. This is called an exception. It's telling you where it came from. This is the call stack here. So it's telling me that it came from line 9, and it tells me maybe something about, here you go, input mismatch exception. That's not very graceful. It would be nice if the user types something that's not an integer here, not to crash the program, but to gracefully catch that. You can do it. We won't look at it till week, I think, 11 in this course. But if you want to look that up, you can. There are ways to handle that. But until then, we'll assume that if you're asking for an integer, the user will enter an integer. They may not enter the correct integer, so you will have to check for that. But they may not enter an integer. But they will enter an integer. So there you go. If statements, Boolean, that's basically it. And the while loop. If we go take a look at the guide, but there's more to say, so we're not done yet. So here's the side-by-side comparisons of the if statement. I'm trying to point out a few things. Boolean expressions in brackets, code blocks in curly brackets. There's no elif. And here's my advice: always use the curly brackets. And then here, Boolean expressions pretty much work the same way, except there's just a direct translation. And is double ampersand, or is double bar. That character, I should say, by the way, is on your keyboard. Usually above the enter key, there's a slash and a big double colon. I wonder if I can hold this up and show you. On my keyboard, it's right there. It doesn't look like a bar on the keyboard. It looks like a double colon on a lot of keyboards anyway. But shift and that will enter that bar character, that pipe character. You might know it from your Intro to Linux course, actually, since it's used a lot in Linux commands. And then the not is the exclamation mark. Okay, and yeah, you can also, because of Python is a bit more forgiving about, this isn't the right Python syntax. I'm going to have to fix this. That's not correct Python syntax. Python's a bit more forgiving, I think, about types. So you can compare, I believe, maybe, the numeric x to the string x. I know it would work for a less than. It might actually not work for an equals, but it never works in Java. So x equals 5. If x is an integer, you can't do that. So over here, if I say, well, n is greater than the string 0, that immediately gives me an error, a syntax error too, not a runtime error. Okay, so your types have to be compatible on both sides of the expression. Okay, now here's the while loop down here, by the way. Oh, look, another countdown with blast off. Yeah, okay, so I'm just giving you the same stuff that's already here. A while loop here. There are two other things here that I haven't covered yet. A couple of issues. The first is a gotcha to do with strings. So that's part C, and then part E on variable scope here. These are the two extra little things above and beyond the syntax, which is just a direct translation. We have these two little issues that are kind of different in Java. So let's take a look at part C here, comparing strings. I think I have a little bit of code for that already written. Over here under week 2 code, here we are comparing strings. So let's take a look at this code. Now there's a bunch of different versions of this code here. Let me just take these out for a second so we can see what's going on. This is what you would do in Python, and this is what most people would intuitively do. So I've got a little program here. I create a scanner. I tell the user to say hello. I use next line to get their input, and I store it in a string variable called user input. And then I compare it to the word hello. And if it's true, I output you said hello. The problem here is, let me show it to you. Oops, I ran the wrong program. I can stop that here and Control-Shift F10 to run the compare strings file. So it says say hello. I say hello. Just pause for a second to make sure that matches what I was supposed to put. Nothing. Okay, so it didn't work. And if you want to be absolutely sure that the program is working properly, here, let me put an else clause on here and we'll run it again. So again, I'm just supposed to, here, I'll even copy and paste this. Control-C. Supposed to say that, and it's telling me wrong. This is surprising to a lot of people who are familiar to Python and stuff like that. The reason it doesn't work it allows it, but this will almost always be false. Comparing strings with a double equals will almost always be false. And understanding why is to understand why is to understand something deep about the Java language and something really, really important. So I'm going to get out the my there we go. So actually, to explain this a little bit better, let me do this. String compare equals hello, like that. Okay. So now I'm asking, so this piece of code will work exactly the same way. It's just that I've replaced the literal string hello with a variable. This will also do the same thing. The reason why it doesn't work, it's rooted in, get the whiteboard here. It's rooted in the issue that I've talked about before about how there's a distinction between primitive and object types. Oh, that's from my machine learning class last term. Let me clear the canvas here. So let me get this code here. Okay, can I just paste it on the screen? Yes, I can. Okay, it goes in a cursive script though. This is the Microsoft whiteboard, but that's okay. There we go. So there's my code. So what happens here is this. Let me get out my pen. So I have two variables here called user input and compare. Now, if I had an example, let me show you a quick example here. Just make sure I've set this up properly. I'll use the blue pen. Make sure that it's small. Okay. So if I do something like this, if I do int, int a equals 5, int b equals 6, like that, and then I say if a equals b, do something. Okay, so the way I would draw this in memory is this statement here, this int a equals 5 statement. It creates a labeled piece of memory called a somewhere in the RAM of the computer. It marks out 4 bytes, and then it puts into those 4 bytes the value 5. And then the second statement creates an area in RAM, a 4-byte area, asks the operating system for it, retrieves it, and then stores the number 6 there. And then this statement here compares these two things. Okay, so it compares what's in the box for A to what's in the box for B. And then it does exactly what you would expect. So let me just change this to B equals 5. Change that. So now in here, B is actually, hold on, B is 5. So now the statement is comparing these two things, and because they are equal, this will be true. Okay, so I've got two variables, sorry, here we go, two variables both equal to 5. And so what that means is two areas of memory, two separate areas of memory, each 4 bytes long, each with the number 5 in it, and those two areas of memory are being compared. Okay, now what's going on here is in a way exactly the same thing, but because the string is not a primitive type, because it's an object type, it plays out very, very differently. So let me erase this here. This thing became its own object, so I have to actually delete that. There we go. Delete. Okay, back to here. So the situation that I have here is a little bit different. So I have first line here just prints out hello. Second line creates my variable. So my variable is called, pardon my chicken scratch here, user input. Now declaring a string variable or an object variable of any type gets you the same thing. It gets you a 4 or 8 byte area of RAM, but this doesn't hold the string itself. This holds an address where the object is going to be stored. So somewhere else in memory, when I do sc.nextLine, it creates another block of memory to hold that string. And that string is going to say something like hello. So my actual string is a sequence of 5 characters, plus maybe some other information and linked to methods and so on, that exists in memory as a little block. And the user input variable doesn't hold that. It holds a number that indicates where in RAM that memory block is. So what I get is what's called a reference. So this thing here is a reference variable. This object variable is a reference variable, and what it holds is a reference to that object, hello. So that's what this line does. It first creates this little reference, which is a memory address, and then it creates the object. So it's not storing, it's storing a value, this variable, but not the value that in the way that we would think of it. We would think of this as, if the user typed hello, as holding the value hello, but it doesn't. It holds an address where we can find that object that contains the value hello. So then in the next line here, when we do this line, string compare equals hello, I create another variable called compare. This line here, this creates another string object in memory, which happens to also contain the same sequence of characters, but it's a different block of memory. And then it points this variable to that. So what I've got here is 2 variables, user input and compare, that are both reference variables, are both object variables, but they reference a different block of memory. So this is a fundamental difference between primitive types and object types. So again, int a equals 5, int b equals 5 gets you 2 primitive variables, a and b, each of which store the value 5. Doing this, user input equals a new variable gets you 2 variables which store references to objects in memory. By the way, the scanner is the same way. I have sc.next line here. Sc is a scanner object, so sc also contains a reference to some really complicated object out here called a scanner. So we have a third object reference variable here as well, which contains a memory address. So these things are memory addresses. And when I do the next line here, this line right here, I'm asking, is user input equal to compare? It's the same thing. If I go over here and if I say, does A equal B, I am comparing the 2 values that are stored in those variables, A and B, and they are equal. I'm doing the exact same thing here. I'm comparing the values that are stored in these 2 variables, but they are not the same. This variable stores a memory address to this object. This variable stores a memory address to that object. So these are not equal to one another. And that's what's going wrong here. Okay, and this is going to happen for every object variable. Now this is going to be really important, especially when we're creating our own objects and creating relationships between objects. You can really go wrong if you don't understand this distinction and you don't understand how these reference variables work. So this is super important. And there's a handout on it. The handout on it is, let's go take a look at it. It's, go back to the modules. Take it a second. It's this handout here, the extra, 1B extra, week 2 comparing strings, where I make the same point. I have a slightly different diagram here. So here I'm showing you that, if you do string greeting equals hi there, you get this reference variable with the address of a string in memory. And here I'm showing you the structure of the string and the index of each character in the list, because a string is a list of characters. And then when you create another one, user string equals input.nextLine, and the user types the exact same thing, you get a new variable and a new string in memory and a reference to that string. So these 2 things are not equal. So I'm making the same point in this handout. So you can't, when you do this, it's almost always going to be false, except in certain special circumstances where the two references actually point to the same object, where they actually have the reference of the same object. Okay, so I hope that makes sense. I can go over it again in the live class if you guys have questions about that, but that's what's going wrong. And the way that you have to fix it, if you think about what is it we really want to do, Let me show it to you actually in this one here. What we really want to do to find out whether two strings are equal is go through them character by character and see that every character matches. And then we can say they're equal. So really we need a loop. And so in Python, when you do x double equals hello, in the background, it's unpacking that into a loop, and it's going through every single character to make sure that they match. It probably checks the length first. If the lengths don't match, then you can immediately say they're not the same. But if the lengths do match, then you'll have to go character by character to check each one. It's the only way to do it. So there is, thankfully for us, there's a bunch of methods for that. So because strings are objects, they contain methods. So I can do string name dot equals and then put the other string here, and it will do just that. It will go through the two strings and compare them character by character. So if we go back to my code here, I'm just going to back out of this with Control Z because I made some changes here to the original code. Okay, so this is the wrong way to do it. If I comment that out and then bring this one in, this is how you're supposed to do it. So this should now work. Also, I'll say hello. Yay, you said hello. And we should always, when you're testing, you should always test the case where it doesn't work. So hello with a lowercase h should not say hello to me, right? Because it doesn't exactly match this string. Okay, and you've got a bunch of other options as well. You've got equals ignore case, which is a different method, which will work for if I go hello with a capital O on the end, it'll still say you said hello, only if it doesn't match, like this. Will it not say hello? You can also do, there's a bunch of other ways to do comparisons. Here's a neat little method, starts with. There's also an ends with method. So say hello. Hello there. Nice to meet you. This starts with hello will come out true because the first thing is the word hello. And you've also got, here's another thing I'm doing. Okay, so this one's totally different. This calls two methods. So I take the user input, I call to lowercase, which will take whatever the user's typed and force it into lowercase. And then on that whole string, the lowercase version, I do a compare to. Compare to is useful for like dictionary lookups. So if the string here comes before this string in alphabetical order, it'll be, I believe, a positive number, and if it comes after, it'll be a negative number, and if they're equal, it'll be 0. So this is just another way of doing the same thing. A case insensitive, if I do hello, it'll say you said hello. But compare to does more stuff than that. And these are reviewed. We reviewed them last week, but here they are again. Compare to, ignore case, equals, ignore case, and equals, and so on. And there's a little bit of advice here. If you're doing yes, no answers, this is a cute little trick too. Force it to lowercase and then take a look at just the first character. And if it's a Y, then take it as a yes. So that way the user can type Y, yes, yeah, yep, and all those things, and they'll come out as yes as well. And there's a bunch of other methods here as well too. Okay, so that's part C about strings. I did say this was going to be a longer video. The other videos are going to be shorter this week. So let's just review what we've covered. We've covered the if statement. We've covered Boolean expressions. This was just a straight translation. We've covered the while loop, again, straight translation from Python to Java. Now I just talked about comparing strings. So in Python you would do this. In Java you do this. And you can't use the double equals for strings. It's really important that you understand that and that you understand why. So make sure you review my explanation and bring any questions you have to the live class. The last thing I want to show you, which is a little bit different, is variable scope. And I think I have, oops, not here. I think I have some examples that are pre-baked for this too. So basically, variable scope is about where and when you can access variables after you've defined them or declared them. I'm not sure if it's something that you explicitly looked at in Python, but variable scope in Python is very simple. A variable is either global or it's local to a function. So hopefully you've heard those terms before. If not, we can talk about it more in the live class. So if you declare a variable inside of a function, it's local to that function. If you declare it outside of a function, it's global. There's no real global variables in Java because you can't ever declare a variable outside of a class or outside of a function. A variable always has to be inside of something. So no variable names are truly global in Java. And the scope rules are a little bit different. The scope rule is you can't access a variable before you declare it. So that's an easy scope rule. I can't access count up here. Count equals 5. That's going to be a syntax error. I have to declare it first before I use it. That's scope rule number 1. And scope rule number 2 is it's only accessible. This variable is only accessible inside the block where I declared it. So here I'm inside the block of the main method. So I declare it if I declare a variable inside this block, it's accessible from that point on within the block until the block ends. Okay, and where this becomes important is in this next example here. So now I'm in a while loop here. I'm doing a countdown. This is my blast off example again. I should really get a new example. But I'm declaring this variable show inside the while loop, inside this block. So this variable show is going to be accessible here and here. But when we get to the end of the block, that variable gets destroyed. And when we come back up, we loop back up to the top of the block, a new variable gets created with the same name, and that variable is used until the end of the block, and then it gets destroyed. So this variable show is not going to be accessible down here. If I run this code right now, it'll work. Oops. Control-Shift-F10 is what I meant to say. Is it going to work? Oh, there it worked. Sorry. So what it does is it does a countdown from 10 to 1, but it multiplies the count by 2 and puts it in a separate variable and then shows it. So what we get is 20, 18, 16, 14, and so on. And then it says blast off at the end. Now if I try to access this variable down here, this show variable, it's no good. It says cannot resolve symbol show, which is the technical way of saying this variable doesn't exist right here. And the reason is because of block level scope. So this variable, because I declared it in there, it only exists inside this loop. So this will sometimes sort of bite you. You'll declare a variable somewhere and then want to use it outside of the block where you declared it, and you can't. So notice this variable count is still accessible inside this second block because we're still inside this block. We're nested one block inside another. But we can't, so we can go from an outer block, we can access, inside an inner block here, we can access the count variable, which was from the outside block, but we can't out here access a variable that was inside here. So the fix for this is simply to declare the variable up here instead of here. So now the variable is declared up here, which means I can access it down here. So it's not red anymore, but I am still getting a different error down here, and we'll take a look. It says variable show might not have been initialized. Okay, so when you declare a variable, Java's pretty good at detecting when you declare a variable and then try to use it without having given it a value, like this. So for example, if I get rid of that, it says variable count might not have been initialized. And it says might not because it's hedging its bets. It's very difficult for the compiler to tell whether this block of code is going to run. If this block of code runs, then show gets initialized. But if it doesn't run, it doesn't. And because it's difficult in the general case to figure that out. This goes into theoretical computer science. This is a problem. This is called the halting problem. This is related to what's called the halting problem. It's impossible actually to solve in the general case. Now we can look at this and we can see, yeah, it's definitely like count is 10. It's going to get past this Boolean expression, and it's going to get initialized. But because it's inside of a conditional block here, Java just to be on the safe side just says, you might not have initialized that. So what we have to do, the fix here, is just to initialize it to some number up here. Doesn't matter what, maybe -1 to indicate that it's not meant to be a real value. That satisfies the compiler, and now I can actually do this. I can run this, and I can access the show variable outside the loop. Okay, so this is a silly little toy example, but this kind of thing happens a lot. You have a variable that you're computing inside of an if statement or inside of a loop. and then you want to access it outside of that, that means that you have to declare it up here above the block. And sometimes it means you have to give it a dummy value to satisfy the compiler. Okay, there's a second one here, scope exercise 2. Same thing. If you could take a look at this code and run it. I want you to do this one on your own, and we can take it up in the live class. But I want you to run it and see how it works. And then I want you to remove these this commenting. I think you can do this in IDE with /. Yeah, // is really handy. If you ever want to comment out a block of code, // comments it out, and then // again toggles it back in. So just highlight this and hit // and it'll toggle it back in, and you'll see the error, and then you got to figure out, what do I need to do to actually fix this error? So, spoiler alert, it's a scope error. Okay, so remember the scope rules, here they are. A variable is accessible after it's declared and within its code block and nowhere else. So it's not accessible before it's declared, and it's not accessible outside of its code block. So I'm going to leave you guys with that, and I would also like you to try exercise 1G. There's a bunch of exercises here for basic flow of control. Honestly, the more of them you do, the better, but I would like you to try 1G. So it says, write a program that asks the user to enter 10 numbers, there's a loop, and outputs the range of numbers that they entered and the average of the numbers that they entered. So if I entered numbers from 1 to 10, it should tell me that the minimum was 1, the maximum was 10, and the average was whatever the average is. There's actually 3 problems here. There's keep track of the minimum number, keep track of the maximum number, and then sum up the numbers and divide by 10 to get the average. So you could take them one at a time, and even if you can just solve one of them, I think it's worthwhile. Use the minimum and maximum ones, require the while loop and if statements in order to work. So give that a try, and we can take that one up in class if you want to. Okay, so that was my super lengthy video. Hope you hung in till the end. Again, the beginning part I think is really easy. It's just translations, but then the scope and the string stuff is super fundamental and important to the Java language. So I hope that you hung out for that. And again, bring your questions to the live class. In the next videos, we're going to go through other loops and other selection statements, and I think we'll be able to plow through that stuff a little bit faster. Okay, see you in the next video.